Hey QED coders, this is Michael, and we are talking about historical modeling. Jan is usually with us. He's unable to join us today, but if you would like to join, go to historicalmodeling.com. Actually, not historicalmodeling.com. I need to update that site. Immutablearchitecture.com, and there you will find a link to our Discord. Join us, have a conversation about how we can use immutability and other ideas in mathematics in order to make our distributed systems and other software more reliable. So today we are going to be talking about a particular pre-baked architecture and the idea of pre-baked architecture in general. The idea is that the application that you're trying to build should not influence, or at least very slightly, your architecture. Now, this is this is something that we see in practice all the time, is that you want to design a system, so then you break it down into different bounded contexts, and those words from the domain, like the sales bounded context and the catalog bounded context, and the ordering, the purchasing, the logistics, those words are domain words, and they end up being names of services and names of queues and names of things that show up in your architecture. The architecture should not depend upon your application. Why? Because architecture is the thing that is difficult to change. Architecture is the set of decisions you wish you'd gotten right at the beginning. And so if you have to change your domain, if you have to change the application, the problem that you're solving, which does happen all the time, then you end up having to change your architecture to match. And architecture is hard to change. And you're making a change after you started, and you didn't get it right when you started because you didn't know where your domain was going. So, what if our application architecture, our system architecture, did not depend upon the application? Then you can make application changes and not impact your architecture. They would be much easier to change. It would be much easier to deploy. You could run different versions of the application at the same time on the same architecture. It just opens up a whole bunch of possibilities that frankly make things a lot easier to deal with. Also, you would be able to pre-bake an architecture, make a bunch of architectural decisions without even knowing what application you're going to build. And you can put that on a shelf. And then whenever you need one of those applications, you can pull that one off. And that means that now this is not just bound to your organization. It's not bound to even an application service provider like Improving. Instead, this can be an open set of pre-baked architectures for anybody to use. They just make the right decisions. Pick the right thing off the shelf. Give it a try. Say, yeah, that's the one that I want to use, and then start building their application. Now, we've seen this work a few times. So Ruby on Rails is a great example of a pre-baked architecture. 37 Signals was building their apps, but they didn't know what apps you were going to build on it. Still, they published that architecture, and many people picked it up and built all sorts of different things. So the lamp stack is a closely related one. So these are architectural decisions that have already been made, and those particular architectures can't scale to do everything. That's why you need a variety of pre-baked architectures. But for the things that they do it well. So I want to share with you a particular pre-baked architecture that I am working on right now. And you can find this in the GitHub repository, github.com/Michael L. Perry, remember the L, /GameHub. So GameHub is a pre-baked architecture that I am right now constraining to multiplayer games. There's actually not too many decisions in this architecture that are constrained to games, but and so this will eventually expand and become a bigger architecture, but for right now it's for games. And that makes it really fun, really easy for people to run a workshop builds, each person build their own game, and they're all building on the same architecture. So the GameHub multiplayer game platform template, it provides all these capabilities. So we've got real-time multiplayer gameplay, multi-tenant architecture, so that you can support multiple organizations within this thing. That kind of comes for free with Janaga, because Janaga can only work in a multi-tenant fashion. This one is based on React, so I will have other pre-baked architectures that are focused on the .NET stack. So we'll have one that does a Blazor architecture. We'll have some that are more focused to mobile. So those will be other architectures. And of course, there will have to be one that does web and mobile. It'll be kind of a combination of those. So distributed data management through Janaga's fact-based architecture. And then we've got OAuth for authentication and Docker, so that we can test the whole thing locally and use that to deploy if we so choose. So what I want to walk through is this getting started section here. I claim here, without any evidence, that you can get started in 10 minutes. Let's start the clock at, well, not quite yet, I'm still yapping, but let's start the clock and see if we can actually get done in 10 minutes. The idea here is that that the application developer should be able to be up and running, developing just their own application, their own game, in a matter of a few commands. This is basically right here. This is where you can start working on your own game, and you don't have all the pieces put together yet. But then step 4 is where you really launch the full environment, and then you can bring in the multiplayer capabilities. You've got your actual Janaga replicator that is moving facts from one instance to another. You've got your authentication built in there. That's where you can start to really test out your authorization and distribution rules. So all the pieces fit together there. So we're going to try to get through step 4 and see how well this works. Now, as I usually do on this channel, I did all of this work on a laptop. So that was my Windows or my Mac laptop, and I am doing this stream on a desktop, and this is on Windows. So this is the first time that this machine has ever seen this code, and in fact, the first time that this machine has ever seen, or this operating system has seen this code. So we will see if that turns out to be a good choice. Yeah, it usually doesn't go particularly well, but that makes for good content, and yeah, frankly, that is a good learning opportunity. So we are going to start with our terminal, and I want to go to the projects folder. Oh, yeah, I'm in WCL. I don't have the projects folder there. I've got the projects folder here. Yes. Okay. And then, what have I got in my projects folder? I want to do, let's do, yeah, I can go ahead and clone it straight here. It'll be fine. So let's go ahead and clone it. And then we change to the GameHub app folder, and we do an npm install. So the first thing we notice is a whole bunch of deprecated npm packages. So probably need to do an npm update at some point, so that we can take care of some of these things, some of those things. But we've installed everything. Where we just did that install, if you take a look, we are inside. Let me make sure that everybody can see that. Yeah, we are inside of the app folder, which has a whole bunch of subfolders. There we go. That's a little bit easier to see. So we've got different subfolders for different apps. This is a monorepo. This is one package JSON at the top, and each one of those has their own separate package JSON. So I'm burning up my 10 minutes. All right, let's run the build for one of those packages, the GameHub model. So npm run build model, and that does the build just for that that package. But you'll see here it's doing the build in several different forms. It's doing ESM, CJS, well, two different forms then. So those are two different package or module loading, anyway, module loader systems. CommonJS, ECMAScript modules. And so those are for running things on the server in Node and running things on the client using Vite. We need the model on both, so we do both those builds. And now, let's see if we can do an npm run dev admin. So this builds the GameHub admin application, which depends upon the model, and that starts it up in Vite. So this is a React and TypeScript application running in Vite. And as you can see right now, it's not doing anything that admin like. It's just demonstrating that that it can reference the model. So so here, in order for it to render this page, it had to actually create instances of those model objects, and then it just JSON stringified those things. So out they are. So I'm going to continue to evolve the admin, and this will actually be the admin application. And when you run it, most importantly, when you run it using the npm run dev :admin and the npm run dev player, that will start it in developer mode so that as you make changes, you can see those changes immediately. Let me kill this just for a second so that we can say code. We're going to open up Visual Studio Code in that GameHub folder. There's our VS Code, and then I'll start that up again. And so, boom, that starts back up. Yep, don't need two of them. And now, yes, I trust those authors. I've already got it open in the browser. Now I can make changes inside of GameHub admin in the source. So like right here in the app.tsx, I can say the sample user right here, I'm creating a new user, admin at gamehub.com. So here's my user, and I can see the sample user. Oh, I'm not outputting the user. Let's pick another one then. Let's go with the sample tenant. Okay, yeah, you can see the creator is right here. So let's go to Michael at qedcode.com, save, and you'll see it immediately updates in the browser. So that kind of experience you get at developer time, and that will also, once I get the rest of the admin application up here, will be a way that you can put in some sample data, some sample facts, without connecting to a real replicator, without persisting those facts anywhere, and then you'll be able to do quick modifications to your game. So that's the first experience that I want people to have, is just run a Janaka application in developer mode, create facts, create specifications, update your model, see how things change. But that's not where I want you to stay. You need to solve a whole bunch of other problems. You need to solve authentication. How are your players going to log in? You need to solve configuration. How are your administrators going to configure your environment? You need to solve deployment. So all of these things, you need other components, other services in order to solve. So that's what this full environment is all about. So let's kill that. And then I'm going to go back to the GameHub directory, run the script to init mesh. Then I'll change to the mesh, do a docker compose pull, docker compose up, -- build, and that will build all of my applications, build those Docker images, and then bring them up in a Docker Compose stack. All right, so the first thing that it did here, I'm not certain why it's paused, but the first thing that it did here is that it ran the init mesh script. And so this is going to take your example.env file and create a real.env file. And then it's going to initialize some secrets. So we've got our Postgres password, JWT secret, player, JWT secret. So everybody gets a random set of secrets. They're not checked into source control, and you never share them with another developer. And then we set up some directories within the mesh and generate some secret files so that the services can talk to each other with those shared secrets. Now we've got the environment set up. Everything is good. Is it waiting for... No? I'm not certain why it paused there. So it should be moving on to... I'll just hit Control-C. Okay, well, so it's moved on to change directory to mesh, because we're in the mesh folder now. Is it trying to do the docker compose pull? Is it stuck on that? Docker compose pull. It looks like that's where it's stuck. Wonder what is going on with that. Let's take a look at Docker. Whoop. So I've got Docker up and running, and so this is going to create a new stack called GameHub. But yeah, pull is not working. Well, let's do our update. I don't know. Let's update on the stream. Let's do the install. Hey, Docker shut down. Well, yeah, because it wasn't working. Okay, well, this is eating my 10 minutes. But let's see if maybe it's just just a version thing. I don't know. It should not just pause like that. Why are we not able to? Are we not able to connect to Docker Hub? While it's doing that, let me just double check. Here's Docker Hub, hub.docker.com. Let's sign in. Make sure that we have access that we need. Looks like this is running. Oh no repositories. Well, they're in the Janaga organization. Yeah, there's my Janaga replicator. Okay, at least the interface to Docker Hub is up and running. Yeah, I'm extremely likely to show everybody. Yeah, I'm showing it right now. Okay, boom. So this is going to pull a bunch of images that are inside of that service mesh. So let's walk through that. Let's talk about those services while Docker is reinstalling. So here we've talked about the app folder. That's our mono repo. So we got a big old package JSON with some workspaces, and then each of those workspaces has its own separate package JSON where you can set up some dependencies. So that's kind of the npm mono repo thing going on. That's how the admin application can get access to the model application, because they're in the same mono repo. But over here we've got mesh, and this is where we've got our Docker compose. So this is pulling in anytime you see an image name here, it is, we're trying to pull those images. Let's just see real quick how close we are. Hey, it's starting up the engine. All right. We still see some components have new versions. I don't know. Did that work? So let's do a Docker Compose pull. There we go. Now it's working. And so you can see this is pulling down all of the images that we are going to use to create these different containers within our Docker Compose stack. So some of those are things like Postgres and Nginx. And then we've got this this really cool one, FusionAuth, I've showed on the stream before. We'll see that again. This is an identity provider that we're using for the admin login. And then we've got some things here that say no image to be pulled. That's because we're building those images within the Docker stack. And of course, right here is the replicator. So this is the Janaga replicator. That's the one that I was just logged in over here. Well, I closed the tab. Let me reopen the tab. This Janaga replicator right here that I've got published for everybody to use. So this is an application. Oh, don't look at that. That's because it's based on the Postgres image, which has some problems. I need to work on those things. But the Janaga replicator is an application agnostic backend, so that you don't have to deploy new code to the backend. That's another way that supports this pre-baked architecture idea, is that backend is just pre-baked into the architecture, and you don't need to build a new one. It's really cool. So we've pulled all those images, and now let's go back to the instructions. How are we doing? Oh yeah, we blew our 10 minutes already. So now we're going to do a Docker Compose up -- build. And so this is going to go through some of the builds that are in the Docker Compose file and run all of those. Fun thing is, it's running them all in parallel, so you get to see all these things happening all at the same time. If we go back here, yeah, some of these containers have images that we just pulled, like those. And then some of the containers, like service IP, have a build, not an image. And so you build your own image using this folder as context and this Docker file. So it's just like docker build -f Docker file, and the folder is app service IP. So that means that is going to come over to, right here, app service IP, that's the service identity provider, and it's going to use that Docker file right there. And it's going to use all the context that's just in this folder. And so we are going to build our service identity provider. Now I will talk about what the service identity provider is once we get everything up and running. Okay, we ran into a build problem already. All right, that's why we do this on stream, so I can't hide. Yep, we have a problem in relay service. This is the newest service. Oh, I just made this change last night, and I thought that I built it and tested it. But yeah, here we're seeing that the bundles property doesn't exist on relay config. Well, that's because I just removed it, but I didn't realize that observability service was looking at it. So let's fix this bug real quick, and we will make this part of the official thing. So we are in relay service. So that's one of the apps. Here's our relay service. And we are doing source services observability service. And yeah, look at there. Well, some of those are just because I haven't installed up here. So I did the, if you remember, let's go to the app folder. I did the npm install from here, and that installed all the packages But yeah, for some reason we're not seeing Axios here. Let's go down to the relay service and do an npm install at this level. And I think what you see here is that the install from the parent level installed all of the common dependencies. The install from the child level installed these specific dependencies. So that cleared that up. But now this one right here, check if bundles are configured. Well, they're not. There's no reason to configure bundles in the relay service, and we'll see why. So we don't have any bundle promises, and that is not going to be true. So therefore, let's see. Wait, this is still trying to get bundles. So this relay response, I think I probably need to propagate this a little bit more. Relay response should not even include bundles. Nobody should be dependent upon that. All right, let's do another npm run build from down here, and let's see if we can build. All right, have more errors. Okay, yeah, not using that one. Good, thank you. And check bundle is never called, right? Of course it's not. Oops, I just dragged something, didn't I? There's terminal. Yeah, spell checker, get back up there. Yeah, there we are. What just happened? Okay, we're back to my terminal. All right, so now we don't need check bundle anymore. Get rid of that. Does that take care of everything? No, come on. npm run build. Okay, now that takes care of everything. Let's do a checkout-b to create a new branch, and we're going to say remove bundles. That is what we want to commit to. Oh, we don't want to commit to that. We want to commit to that. That's the one. So let's remove all of those bundle objects, properties, whatever. Okay, and this one, we don't need that change. Let's undo that change. Perfect. Publish that branch. Alright, so I need to sign in. Let's see if we can do a sign in real quick. Come on. Are you signing in? I can't see if you're signing in. Well, hopefully it's signed in. Okay, yeah, I didn't have a pop-up. All right. Yeah, it says that it's signed in there. So now let's create a pull request, which I can do. Oh no, I don't have my GitHub over here to the side. I can't create a pull request this way. But let's do a little sidetrack. Have you played with RuCode? Let me tell you about RuCode. RuCode is this this awesome, I'll use the word agentic, AI application, or AI developer assistant. So you've got these different agents, and you can create your own. For this project so far, I haven't created my own, but I have in other projects. And so each one of these is focused on a particular task. And the orchestrator is really special because that can delegate to the other remotes, the other agents. So this has MCP support. So I should have my MCP servers all set up. So I should be able to say, using the GitHub MCP server, create a pull request for this branch. Now, rather than just send in that lame prompt, let's go ahead and embiggen the prompt. This is going to, using the particular mode that I've got selected, which actually I don't want orchestrator for this one, I want code for this one. it's going to give a more concise or a more descriptive prompt. So, using the MCP server for GitHub, create a comprehensive pull request that includes descriptive title changes, detailed description, appropriate labels, milestone assignments, and proper reviewer arguments. Wow, a lot. So, you know what? I really don't want all of that. I don't want any of that. So let's constrain that. These are the things I really want you to do. Title, detailed description, purpose, scope, go. So this should be able to use my GitHub MCP server, which I have just this morning configured. It doesn't look like it's finding the GitHub MCP server, but yeah. Well, it's getting a log of the changes that I made here, and then it's going to at least come up with a description for me of those things. Okay, yeah, here it's using the MCP server. So it shows you this is the tool call I'm going to make. Wow, that is a big description. So a tool call is just a JSON object. So I'm going to create a new PR. The head is remove bundles and the base is main, and that's all the stuff that's going to be in that tool call. Here's the body, here's the title. Yep, that looks like a good PR. Oh no, error executing. Okay, now it's just going to fall back to using the GH command line. That'll work. That'll work just fine. Okay, so let's use GH to create that pull request. Same description. This is cool stuff. This is really cool stuff. All right, let's run that command. Boom. Now we have a pull request, and here it is. Control click on that, and it opens. There it is. So here is our new pull request. It's a very descriptive pull request for a very small change. Here we go. Just remove those things. That's it. Okay. Yeah, I reviewed it. Everything looks good. So let's merge it. And then for good measure, let's delete that branch. Okay, now we are back here just to complete the cycle. If I do a fetch, I can see there's a new main out there. I'm going to check out main, which now I am 2 commits behind, the one that did the work and then the merge commit. So now I'm going to pull, and then I'm going to scrub. This is an alias that that I added to my system that'll just get rid of any branches that have already been merged into main. Keep things clean. Now, let's see if we can return to GameHub here. I was in the middle of doing this Docker compose up -d to disconnect and -- build to build all of the images. Okay, now it is working on that relay, so it made it a bit further through that. And then, yeah, this is one that I'm actually going to change right here. It might be hard to see, but it's doing the admin builder. So it's building the React application within the Docker Compose. I thought that I wanted to go that way. That's not the way I did it for code launch, and now that I've kind of lived with this for a little bit, that I don't think that's the way I wanted to do it here. I'm going to replace that with a separate npm command that will build your React applications, bundle them using Vite, and then copy them to a folder within Nginx. And that way you don't have to rebuild your stack in order to deploy changes to your JavaScript applications. And furthermore, that supports the deployment through CI/CD. So if you want to deploy those applications to a static application server, then you can do that. And static websites in Azure, for example, or onto a CDN. That should be perfectly fine, but if you're building from within Docker, then you can't do that because static hosts don't support Docker images. All right, so we've built all of these containers. Now we built all these images, and now we're creating these containers. We've also created these networks and volumes. So the volumes are they contain application or data for each of the different services. I've given them names so that I can destroy these containers and then build new ones, and it'll just mount that same volume to the new container. And then we've got networks, and these are specific networks within the mesh that these services connect with each other over. So it's not just everything on one network, it's isolated networks. Make all those great architectural decisions right up front, pre-bake them into this stack, and then you don't have to do this every single time. That's the whole idea. All right, trying to start GameHub Nginx, and it says that ports are not available. So there's already something on port 443. What could that be? I don't know what could be running. Let's first of all see if we can just eyeball it. Do I have anything in here that's running? Nope, nothing else, just GameHub. So yeah, now here's our GameHub with everything running except for Nginx. Admin Builder did its job, and now it's done. Yeah, there's something on 443. So now there's a command that I could try to memorize to say, hey, how do I do that? But you know what? I don't remember what that command is. So for this kind of thing, I'm going to go ahead and put root code away. This one is a nice, easy job for my other friend, Copilot. And let's just ask, something is running on port 443. I'm in Bash. Unfortunately, that's on the other side of the screen. You can't see that behind my head. But, yeah, LSOF, that's the one. So let's copy that. Actually, I do have a terminal right here. I'm in WSL. Let me just go ahead and run that in the terminal. Boom. Type in your password. There's the stuff. Okay, so that's what is running. GitHub.com ID. Is this actually my MCP server running on 443? Could that be it? Let's see. So then I want to sudo kill a process ID. I got a lot of... Okay, it's all one process ID. Let's just... Okay, we've got Node running there. Probably I have the MCP server running in Node. Let me just see real quick. Here is... Let's go to MCP servers. We are running this. Let's just go ahead and turn that off just to see. Was that the one before I do a kill? No, that's still running. Okay. So let's do the sudo kill that process. Oh, it was root code, but not a particular MCP server. Root code itself. Wow. Okay, that's good to know. And it came back up, so I'll bet you, yeah, it's doing that again. Oh, wow. Why didn't I run into this on the Mac? There we go. Something that's good to know. So let's go ahead and, how do I just shut down root code for now? That's the activity bar. Can I Here's my account. Here's my settings. Okay, Claude 4 Sonnet is experimental. Let's go back down to Claude 3.7 or oh wait, oh, I'm using Copilot Claude Sonnet. Oh, I should be using my my API key. Anyway, that's not important. That's not what we're trying to do. We want to just shut this down. You know what? I'm just going to kill that because we're working here right now. Let's see if we can build and start this stack. Okay. Do I remember the lsof command? Oh no. Okay. Let's take a different approach. Yeah, how are we doing on our 10 minutes? Yeah, not so good. Let's take a different approach. We want to change the Nginx config so that it doesn't try to open something on 443. Actually, I'm not certain why that's there. So let's do code ... again to open at the GameHub application. Go ahead, RuCode. Go ahead and take that port. It's all yours. I'm going to move. So inside of the mesh, we've got our Nginx folder. This folder has hey, stop. Come on back. Nginx folder. So this folder has our Nginx config. That's really where we want to look. Don't need chat for right now. And so here we've set up a server to listen on port 80. That one's not causing us any trouble. But then there must be another server at the bottom. So here's our HTTPS configuration. This is a server that listens on 443, but it's commented out. Why would it be trying to listen on 443 then? I don't understand. We've got an SSL folder here that is just in case, like if you look at the commented out portion, this is where we can terminate TLS within Nginx. This is here so that we can modify this Nginx configuration for a production deployment if we choose to do that. Or we can terminate TLS prior to hitting this, and then we can serve everything through port 40 or 80. We also have this application that I really want to show you. That's just some HTML and CSS and JavaScript up here. But we'll get to that once we can figure this out. So, Docker Compose. Maybe this is where we said, I want you to bind 443. So, let's look for our Nginx. Content store, relay service. I could just search for Nginx, but there it is. Yeah, there's where we are binding to port 443. So let's git checkout -b, and then port conflict. Let's delete that, and let's see. Don't bind to 443. Commit that. And in the meanwhile, let's see if our Docker Compose up build works this time. And now it works. Okay. So it wasn't that Nginx was actually trying to listen at port 443, but it was that the Docker Compose said, I need you to reserve 443. So what we can really do is change any of these external port numbers. I can't remember which one is external, which one's internal. I always have to look that up. But you can just change the external port number to a different port, and then you can use that for testing. So if port 80 becomes a problem, and so far it hasn't, but if that becomes a problem, then we can just change the mapping there. All right. What have we got now? Let's go back to our instructions. We have just done a Docker Compose up -- build, and now we want to navigate to localhost setup. Boom. Here we are with our GameHub setup wizard. This is one of those two applications that we found inside of Nginx. So what this application does, we've got our 3 setup steps: Fusion Auth configuration, tenant creation, and service principal authorization. And then it shows you these are the steps to complete the Fusion Auth configuration. And so this way, you don't have to follow a README and do a whole bunch of little things. This one is actually checking, have you completed this? Is the configuration done? And then, if not, showing you that's the next thing to do. So let's go ahead and continue walking through this. We want to access the Fusion Auth admin interface here. Boom, and it opens up a new tab, and now we've got Fusion Auth. This is the first time that you run Fusion Auth. It says I need to set up an admin user. So let's do Michael at qedcode.com. And then we type in a nice simple password. This one is not my secure password or any secure password. And accept license terms. Okay. Continue. If I look here, now it says create an API key. If I come here, the way I do that is I do this setup, and I see lots of setup steps. I just want to do create an API key. There it is. Copy that. And then I want to enter the API key here. It's okay, you can't reach my machine anyway. And then this is what I want to run in the terminal. So let's copy that. Meanwhile, over here, I want to save and continue, skip the rest of these steps, and complete. So now my initial Fusion Auth setup is complete. I've got an admin user and an API key. All I need to go on to the next step. The next step is come back out here to the root folder and run that script. So I'm going to run the setup script, pass in that API key, and why is scripts? Oh, that's because this should be set up Fusion Auth. There we go. There's a problem in the setup app. So this is going to, oh my goodness, build the setup application, and the setup application has a bunch of issues. Can't find types. I thought I fixed that one. Wow. Okay, so got some things to fix there. The idea being that the setup application is going to use the Fusion Auth API to configure various things. So first of all, it's going to add a new application for GameHub. So we'll have that GameHub application here. It is going to, not customizations, but under settings, here's the API key that we already created. But then it's also going to give you a new key here so that it can use that signing key to authenticate the admin that logs in with Fusion Auth. It's also going to set up OAuth, which I think happens in the application. Yeah, so once it creates an application, then we will be able to set up our OAuth provider. So all these things will get set up, and so the script does that all through the API key when it builds and runs. And so that way you don't have to go through all that setup yourself. You just follow these, nope, not those, these simple instructions, and everything should just work. Well, when it does just work, then I will show you. Oh, mark as done. Yeah, we can probably take out the mark as done because we're not using any other kind of store to figure out what's done. We are actually checking to see, is this thing working? So we'll come back to this in a later episode for right now, to kind of round things out, I want to show you the other application that is deployed to Nginx inside of this bundle. And we've got the status page. So here we've got different applications that are running within the Docker stack. And so we've got the service identity provider, the player identity provider, and the content store. So we'll have other services pop in here as we add them to the stack. But we can see 3 different endpoints. Oh, this one just switched. Oh, they switched orders. Weird. Okay, I'm going to have to fix that. Keep the order consistent. And then, yeah, so you can see healthy, configuration, and ready. So healthy and ready, those are common endpoints that every application should have. The health endpoint is just, is this service up? So hit that health endpoint, and it always just returns 200. It doesn't do any extra checks. Then you've got your ready endpoint, and that makes sure that, switch over here, and you've got your ready endpoint, and that makes sure that it can connect to all of its dependencies. Like this application can connect to its database, or it can connect to the RabbitMQ queue and pull messages from it, whatever. That's ready. So if an application's not healthy, then the orchestrator needs to kill that pod and create a new one. That's the only way to get it healthy again. If it's not ready, well, killing it is not going to do any good. So it needs to take it out of the load balancer and not send any traffic to it, because any traffic that goes to something that's not ready is not going to succeed. So that's the difference between these two checks. Configuration, this is a new kind of check that I built for this, and that tells you these are the different groups of configuration settings, and it talks about whether those groups are configured. So the JWT group, so have I set up all those JWT environment variables for the service identity provider? And it says, yes, those have been configured. Clients, which clients have I configured for the service identity provider? I've configured the player IP client. Okay, that gets a green check mark. Each one has its own separate set of configuration groups. Player IP also has some JWT configuration settings, and it's got a service IP configuration group that tells it how to find the service identity provider and connect to it, and it says that one's been configured. Those configurations happened in that init mesh script where it randomly created some new secrets. So these two are now talking to each other with those secrets. So the content store, need to take a look at why that's not coming up, but that's not an important part of what we're doing right now. When we take a look at the setup wizard, this wizard is actually looking at those configuration settings and saying, okay, for FusionAuth configuration to be done, I need the player IP, something or other. Something needs to be configured. I can't remember how it's mapped, but it's like that service, that configuration group needs to be set. This whole set of services with their configuration groups need to be set. If that's not done, then we are not finished here. And when you follow these steps, the script will configure all those things. So, so this is just a short and knowledgeable consumer of this information. But now here you can see it in all of its detail. Okay, so when you go through all of these steps, then we should get to the point where all of these things are green across the board here. They're all configured. And then if that all works, we'll see that everything is healthy. It'll all have started up. And everything is ready after it's all able to connect to everything else and make sure that those connections are good. And then we'll be able to actually play our game in a multiplayer mode through this Docker Compose stack. That is the goal for this whole pre-baked architecture stuff, is that I should be able to clone this repo, follow some steps that are, hold your hand and you're guided through that, and then you can start customizing your application. All of this happens without even knowing what your application is. And when you start customizing, you're just working on the parts that are application specific, which in the case of a Janaga application are really just the front end parts. The backend, the Janaga replicator, is application agnostic, so you don't need to rebuild a backend. And that is what we're going for. Once we've got a good working GameHub stack, then I'm going to run a class for a set of improvers that we're going to walk through building our own games. It's going to be a lot of fun. And then once we see that that's all working, iron out some of the kinks there, I will open that up to you. We'll run a workshop, and we will build games in the community. So go ahead and clone that repo and follow along, see everything break, and then as we progress, things will start to work. And I will let you know when we have a good pre-baked architecture for you to play with. All right, and until next week, I hope that you build something awesome, and take care of yourself.